Hey everyone, Mr. Bennett here again. We are looking at section 2 now of our energy. So this is energy 2. Okay, and we're going to take a look at a power plant. I've got a diagram of a power plant up today, so we're going to kind of fly through some of these boxes and then talk about the transformations that can occur inside of this plant. So the first thing to know is that power plants all follow kind of the same similar structure, and today we are looking at specifically, this is a non-renewable resource. So these are like a coal plant or a nuclear reactor would follow similar principles, not exactly the same, but this is the general idea, non-renewable plants. And I'm going to do these in blue. So down here, we're going to start over here on the left. In step 1, you have to have some kind of fuel. Your fuel is what we burn, obviously. So this, again, like I said, this diagram has got coal going into it. So there's some kind of chemical change that has to happen. There's energy stored up in this fuel. We need to get at it. So we do that inside of the boiler, B-O-I-L-E-R. So we throw our fuel into here, we start a fire, and if you look really carefully, okay, we've got a blue line that kind of fades out into white. So this is water, actually. And as it heats up, it turns into steam. And that steam is carried through a pipe and into another container, another room, or another building. And this is where the turbine is held. And a turbine is essentially like a big fan, a big propeller, and it is turned by the steam itself. Anytime you want to generate electricity, you have to have a turbine involved somewhere. So we see one here in a non-renewable resource power plant. Hydroelectric power works the same way. The dam funnels the water through a turbine, which then spins, and it spins because we need to rotate a generator. So this generator is a big cylinder, big coil of wire, and it spins and spins and spins, and that's what gives us electricity out the other side. So we go through kind of the 6-step process. Take our fuel, we burn it in a boiler of some kind to create steam, which then spins the turbine, runs a generator, which produces electricity. So that's the core of what's happening inside of this power plant. In terms of all the other stuff going on here, there are a few things that we need to label. So let's jump over here, and I'm going to switch to blue for this. This is called a cooling tower. So as that water is used, so this does two things. As that water is used, it can swing over here to the cooling tower. And what it does is it helps to cool the turbine. So as things are rotating or spinning, just like if you take your hands and rub them together, there's a lot of friction there. There's a lot of heat that gets built up. So we use water to cool down the turbine and make sure everything is running safely. So coming out of the cooling tower then, this is just water vapor, H2O vapor. This is not pollution, and you've probably seen these cooling towers. They're more familiar with things like nuclear power plants, but power plants in general have these cooling towers, and water vapor, the big white puffy clouds, come out. On the other side, this other tower here, we've got a pollutant tower here, P-O-L-L-U-T-A, or pollutant stack is what I call it. And this is what filters out all the particles. So when we burn stuff, we get ash and soot and smoke. This pollutant stack cleans that out. There are EPA guidelines that have to say, or that say this is how clean your waste has to be. So we clean out all the nasty stuff, and what's left is carbon dioxide and some water. And carbon dioxide, remember, this is a greenhouse gas. So this is what starts to hold in the heat in the atmosphere. And the United States, remember, we use a lot of fossil fuels, so we're putting a lot of greenhouse gases into the atmosphere. And then the last thing, down here on the very, very bottom, we're going to jump back to water for a second. When we use the steam to spin the turbine, we can cool it back down, and we actually cycle it, and we pump it back over into the boiler. So this water creates kind of a closed loop if you follow this pipe coming right out of the bottom there. This is called a condenser. And all that does is it takes hot water, cools it down, and pumps it back over to the boiler so we can continue to use that same water as we generate our electricity. So what you really need to pay attention to is kind of this core of the power plant. So starting with some kind of fuel, we throw it into a boiler where it's burned. That turns some water into steam. That steam is then carried over to a turbine, which spins and that turns a generator which produces electricity, and that's what gets to your house, and that's why we see light, or that's how we get electrical power to our house. These other things are important. We will be coming back to them, but really the core of this is how a power plant works. Remember, this is how all power plants work. There are some fine differences, but really we all have to start with creating some heat to turn water to steam to spin the turbine, and this is kind of the core of the whole thing. If you have questions, you can head over to the website and leave comments there, or you can leave a comment below in the video, and thanks for watching.